So we're going to finish module 1 today. If you read the module and watch the recorded video that is related to this module, okay? So I'm just going to discuss more about the figure of merits today and the different calibration, although some of them has already been discussed in what we call the recorded video. Okay. I'm just trying to type the take home for you for today. So, some of you said wala kayong mga mukha. So maybe later on you show up. So we are on what we call an instrumental analysis course, and we're using modern instruments to do the analysis. So whenever you choose an instrument that you want to use, okay, these are some of the questions that you need to ask yourself. What type of information does this method provide? What are the advantages or disadvantages of the technique versus the other methods? How reproducible and accurate is the technique? And how much or how little sample is required? So, first question that you got, what type of information does the method provide? So, will it gives you the quantity or the amount of the analyte that you're looking for? Okay. Now, advantages and disadvantages of technique over other methods. Will there be additional sample preparation that you need to do? Okay, or more preps? How reproducible and accurate is the technique? So how sure are you that whatever you get, okay, is the right result? And then how much or how little sample is required? So if the method is sensitive enough, you just need little sample. But if it's not, you need a little bit more. Okay? Or how much or how little analyte can be detected. So what is the lower limit, okay, of the analyte that is it ppb level, ppm level? And then what type of sample can the method be used with? Will other components of the sample cause interference? What is these other components? Anong tawag natin dyan? Anyone?
Matrix po.
Yung matrix effect. Okay. So matrix effect is really, we could say, one of the main challenges when you analyze sample. Especially if your analyte is not the major component in a given sample. Okay. Now, other things that you need to consider: how fast is the analysis? Okay. So here you're going to question yourself: are you going to use chromatography, which is usually longer compared to spectroscopy? Convenience. At least we have high-end instrument that you can automate, or their analysis are automated. You just program there and then you leave. And by the time you come back a day after, you already have the result. Of course, those type of instruments are what? Expensive. Okay. And it's rarely available in a third world country like the Philippines. And some method required additional technique compared to the other. So how do we answer or address these questions? Okay, so we look at the numerical criteria for selecting analytical methods, and that's what we call what? Anong tawag natin dito? Yan yung tinatawag nating figure of merits. Okay. So whenever we look at the so-called figure of merits, okay, basically, we're just looking at the characteristic of a given method. So these are the numerical criteria for selecting the analytical method. Okay. So the characteristics that we want to know in a given analytical method, they are usually expressed in what? Numerical number. Okay. So other things that you need to consider: speed, ease of and convenient, skill required of the operator, the cost and the availability of equipment, and first sample cost. So what's the difference of this compared to the previous slide? Ano yung diferensya ng slide na to doon sa kasunod na slide? Usually this involves what? Number. Okay, so these are characteristics that are expressed in numerical terms compared to dito. Okay, so whenever you look at precision, bias, sensitivity, detection limit, concentration rate, selectivity, there's a number that follow it. Okay, so if we're going to look at the precision, although I'll discuss it in detail, you look at the standard deviation, absolute, relative, coefficient of variation, variance. You covered this in 32, right? I'm asking questions. Na-cover ba
Yes,
ito sa
sir.
32?
Yes po.
Okay, although
Yes,
we have a review.
generally.
Okay, and bias. What is the other name of bias here? Accuracy. So whether you have an absolute systematic error or a relative systematic error. And then you have sensitivity. Okay, so you have this calibration sensitivity and analytical sensitivity. What's the difference of the two? Okay. So hindi ba pwede silang parehong balat sibuyas? Siguro yung isa, sibuyas na puti, yung isa, sibuyas na pula. Right? And then you have the limit of detection, the average blank plus 3 times the standard deviation of a blank. And then the concentration range, or in other term, this is what? The LDR. Linear dynamic range, from the limit of quantitation to limit of linearity. And then we have the so-called selectivity. Okay, so those are, we could say, the figure of merits that are usually being obtained or determined if you are using an analytical method. Okay, so we could say figure of merits is what? Way for analytical chemists to characterize a method. Okay, so yan yung ginagamit nila para makarakterize ng method. Is this the first time for you to hear this term? The figure of merits? Okay, so if we're going to look at this, what we call we can go on them one by one. So we go with precision. So precision is just what? nearness of data with one another. Typically, an analytical data, they tend to be what? If I ask you, which do you think is easily obtained? A precise data or an accurate data?
Size.
Precise po.
Okay. So ideally, it's easier for you to determine or to get what we call a precise data. So when we're talking about precision, we're looking at how the data are close to one another, reproducibility of the data. Okay, or the degree to which an experimental result varies from one determination to other. So we could say precision is related to random error, accuracy is related to systematic error. So this is the classic difference between the accurate and precise measurement. So here, okay, low accuracy, low precision. Here, low accuracy, okay, high precision. Here, high accuracy, but low precision. Why is it high accuracy? Because you have some data in the true value. And this one, this is the ideal, right? But if we want to be a realist, we go on that. Diba? So idealistic, yun yung gusto talaga natin. But we have to be realist. Okay, so in a realistic world, in a real world, a precise data is much better than, let's say, the other set here. But if you can make it also accurate, then better. Okay. Now, how do you describe this range? What we call this precision. So you can have the range. So that is how spread out they are, the lowest and the highest value. And then the one that you can use to really describe the precision, which is standard deviation, which can be absolute or relative. Okay, so both of them describe the distribution of the measured results about the mean or the average value. And then accuracy or the bias, okay, it just tells us how close are the data to the true data. Okay, but the question is, how do you determine the true value? So maybe you can have, let's say, a standard. Okay, but if you have a sample, it is really hard to determine what's the true value. Okay, so if precision is described by standard deviation, we could say accuracy is characterized by the error. It can be absolute error or relative error. So the lower the error, okay, the more accurate is the sample or the measurement. So error is just the difference between the result that is obtained and the true value. Okay, and as I've told you, all methods, they contain error. The only one that doesn't contain methods is the counting, because they are really what? Exact number. Now, the thing is, we don't really know what we call the true value, especially if we're dealing with samples. Okay? So there are two types of error that we usually deal on. We have the random error and the what we call systematic error. So if you have a random error, okay, it results in the scatter of results centered to the true value for repeated measurement of a single sample. So when we have random error, usually they said we can do anything. Okay, it is an error that will happen whether we like it or not, compared to what we call systematic error. Okay. So if you have what we call a random error, usually it can be due to matrix interferences, mechanical variation, electrical interferences, the variation of your detector, and some problems in your sample. Okay. Now compare it with the systematic error. So if you have a systematic error, usually it results in a measurement exhibiting a definite difference from the two values. It's either what? Too high or too low. Okay. And this is used sometimes in this intrinsic method bias, the instrument bias. So usually kapag if you see your what? Your burette, so you always see what? Lower or higher on that. So usually the value that you have is consistently higher or lower. You can also be due to reagent lot bias, the calibration bias, and within run bias. Okay. So those are the example of what we call a systematic error. Okay. Now, if you're going to plot the number of occurrences or population for each, you're going to form like a Gaussian curve. Okay. So you could see that you will going to get the average and the so-called standard deviation. And then from that, you have the C. Have you discussed Gaussian curve in 32? How to determine the percentage, okay, given your what we call mean and standard deviation? Na-discuss nyo na ba yan sa 32? Class?
Sir, parang ako po sa physics ko po na remember yung term na Gaussian.
Bell curve. Kung hindi Gaussian. Or the so-called normal distribution curve.
Yes po.
Okay, so ito yung normal. Tapos pag nilagay mo ng ganito, yan yung tinatawag na paranormal distribution. So we usually have a stat in analytical chemistry. And I think it's usually in 32. Because here in the course, it's in the analytical chemistry 1. Analytical chemistry 2 is the one that we're discussing. So we're just trying to what we call review with respect to figure of merits. Okay? Now, the next one is what? Response. Anong other word dito doon sa anim? I didn't put response there. What do you think is the response? This is the sensitivity, right? So when we're talking about response, we're talking about sensitivity. And if we're going to look at this sensitivity, typically this is what? The ability to distinguish between the small differences in concentration between samples at a desired confidence level. Okay? And a simple measure of this is what? By doing the calibration curve. So what usually is the sensitivity? Ano yung sensitivity dito sa calibration curve? Anyone?
Yung slope po.
The slope. You don't need to raise your hand. You can just answer. Okay? Kasi hindi ko kita kung sino yung nagre-raise ng hand eh. Okay? So when we're talking about the response, this is the way in which the result or signal of a method varies with the amount of compound or property being measured. So if we have a calibration curve like this, and I have a calibration curve like this, and then I have a calibration curve like this, and then I put A, B, and C, which is the most sensitive, or which has the greatest response among the three. Okay, so you have here A, because that is the one that has the highest slope. The highest slope is the one that is we could say steeper or more steep. Okay. And if you're going to look at this response in terms of the sensitivity, so dito yung meron tayong tinatawag na calibration sensitivity and analytical sensitivity. So what is the difference between these two? If you see the slide, okay, it more on what we call the formula. Okay, so if you're going to look at the slide here, so we have this. This is just a y equals to mx plus b, right? So as you could see here, this is what? The concentration, the corresponding signal, the sensitivity, and what is this? That's your blank instrument. Blank. So what does it mean? Kung wala kayong concentration, kung ano yung signal galing sa blank, yun yung magiging signal mo. Okay? So sensitivity is ability to discriminate between small differences in analyte concentration. So calibration sensitivity is usually just the slope of the calibration curve. Analytical sensitivity, that's the slope divided by the standard deviation. Okay? Now, these two are not synonyms. Okay? Yung analytical sensitivity mo, usually it is interpolated from the calibration curve at the point that was 2 standard deviation from the pitted zero. Okay? So hindi sila pareho. And I think between the two, when we go with the detection limit, usually detection limit is located 2 standard deviation above the average zero value or yung calibrator. Okay? So when you are asked to what we call determine the sensitivity, okay? So you can differentiate it either what? Analytical sensitivity or calibration sensitivity. Okay? So when you have analytical sensitivity, it asserts the smallest amount of an analyte that can be measured in an assay correctly. Okay, yun yung analytical sensitivity. And slope and reversibility of the what we call calibration curve is needed here. So here, method A, we could say is more sensitive than method B. And you can have it sometimes matrix effect. So, pwedeng ang example dito, ito yung heavy metal, okay, in pure water, or we could say tap water. Tapos ito naman yung heavy metal in a more complicated water like environmental water. So you have a matrix effect. Okay. Now the next one is selectivity. So if you're going to look at selectivity, it's not the same as sensitivity. So when we are talking about selectivity, is the degree to which a method is free from interference by the other species in a given sample. So if you're going to look at what we call selectivity, you're able to distinguish the signal of an analyte from the signal of interferences. Usually what? What are the main interferences that we have? The matrix. Okay. So typically express this as a ratio, such as the ratio of capacity factors in chromatography, sometimes called specificity. Okay. So no method is totally free from interference from other species. Magkakaroon talaga ng interference unless you have a pure sample. But the more complicated your sample is, the more matrix effect, the more interference. Now, the problem with this interference, it can increase or enhance your signal or diminish the signal that you have. Okay. So, the way that you look at this, okay, it's just a ratio, such as the capacity factors in chromatography. So if you're going to look at here, you have here the selectivity coefficient, okay, of K with respect to B and A. So the higher the K here, the more selective it is. Now, you can include this selectivity like this one in the slopes of the calibration. Okay, so as you could see there, this is what? Y equals to mx plus b. But there's an additional here. So if you're interested in detecting species A, but the signal here will be a combination of signal from the presence of species A and species B. So in our handout, selectivity is the measure of method's freedom from interferences as defined by the method selectivity coefficient. So mathematically, nakalagay dun sa handout natin, yung signal ng sample is just coming from the signal from A, signal from the interferences, and signal from the blank, or B1. This is the blank signal. And then we have the LOD, and related to this yung diniscuss natin last time, the signal to noise ratio. So here, we can define the detection limit or limit of detection as the minimum analyte minus, okay, the mean blank signal divided by sensitivity or yung slope. Okay, so when we look at the LOD, the limit of detection, we look at the minimum over maximum concentration or mass of analyte that can be detected at a known confidence level. Okay, so detection limit or limit of detection is the smallest concentration of analyte that can be detected by an instrument. Okay, the lowest measurable concentration of an analyte by use of particular instrument. So typically, it is 2 to 4 above the signal to noise ratio. So if you're going to look at the signal to ratio here, okay, you're looking for 2 or better to be considered the minimum ratio needed for a reliable detection of a true signal from the sample. So if you have it here, you can do a detection here by doing multiple determination of the blank sample and then estimation of the best fit to calibration curves. I think in the recorded slide, I discussed there how you measure the detection limit. Okay, you look at the lowest concentration and the blank signal, the signal from the lowest concentration sample and the blank. And then we have this dynamic range. Okay, so here it's just the linear region of a calibration curve where the lower limit is 10 times the standard deviation of the blank. Okay, so when we're talking about lower limit, that's your LOQ. If the LOD is 3 times, yung LOQ natin 10 times. LOD is 3 times the standard deviation. LOQ is at least 10 times. Okay, so the linear dynamic range, the linear range of a calibration curve obtainable with a particular method of a certain analyte. So as you could see here, when you reach this one, hindi na siya linear. So yan yung limit of linearity. So at least meron ibang ibig sabihin ngayon yung tinatawag nating LOL. Right? Questions so far? So maybe we can solve this problem. So what do I need to do here? I'm going to copy the value here. Okay. So I'm going to open Excel. $176, $133, $151, $155, $104, $175, $164, $193, $131, $189. So I'm going to share to you the Excel. So this is the value that we have. So what do we need to get from here? Anong kailangan natin dito? So these are the log concentration. So we need here the standard deviation. So we have here around 27, may nagkamali ata ako. Hindi ito yung dapat na value. 176, 133, 151, 155, 104, 175, 164, 193, 131, and 189. Yun. Doon ako nagkamali. So what do I do? So I have a 28.19 or 28.2. Yan yung standard deviation natin dito. So if you're going to look at our what we call notes, the detection limit is equals to Y blank times or plus 3 times standard deviation. So what's the Y blank? 45 counts plus 3 times 28.2. Ano yung sagot?
$129.6 po.
129.6 or 130 counts. So you can input it in a calculator, but I don't know. When I learned how to use Excel, it's much easier to use Excel. So I'm going to give you some take-home problem. Yun yung parang magiging part ng tinatawag nating problem set. But I can only do one problem at a time. Yun nga lang, hindi pwede mag-Excel sa board, di ba? But if you know the calculator, you can input that one. Tapos meron ng ano doon, ibibigay sa inyo yung standard deviation. Okay? So the next thing that we're going to talk about is the instrument calibration. So paano ba ginagawa itong tinatawag nating instrument calibration? Okay? So we have 3 here. So usually when we're talking about calibration, or the other word that we can use it is standardization. We just determine the relationship between the analytical response from an instrument and the analyte concentration. Okay? So ang pinaka-common yan yung traditionally the use of external standards, which is just what we call the calibration curve. And then we have the so-called standard addition and the use of these internal standards. Okay? So common dito sa ginagawa natin ay yung tinatawag na external standards. And it can be used for what? A single or several concentration. Pwede kayo magkaroon ng single point calibration. Paano ginagawa yung single point? Anyone? Ano yung math principle doon? If you do single point calibration, you're just doing ratio and proportion. So let's say, konti lang talaga yung sample nyo or yung standard nyo. So meron kayong 1,000 ppm, tapos makakaroon nyo ng kanyang signal. So all you need to do is get the signal of your unknown. Okay? So let's say lumabas dun sa signal, 100 din. So kapag meron kang unknown, yung signal na lumabas ay 75, so yung sample mo is 75. But the problem, it is prone to what? Error. Kaya ang usual na ginagawa yung mag-prepare ka ng standard of exactly known concentration covering a particular range. And then you prepare a blank. Okay? You define a blank as everything in the sample except the analyte. So pwede mo bang sabihin ang blank ay pwede laging water? Yes or no? Kapag nag-true or false question ako, water is typically the one used for blanks. True or false?
No po.
The answer is no. A definition of the blank is everything in the sample except the analyte. And then when you're going to get the reading, you have to always have the so-called blank subtracted. Okay? So that the response will just be coming from the analyte. Kung hindi mo pwedeng i-blank subtracted, kunin mo yung signal ng blank, tapos lahat ng signal ng sample mo, i-subtract mo doon sa blank. And from that...
So, sir, yung blank...
Okay?
Mali.
Chappy.
So, sir, yung blank po, yung nasa nga po. Sir, yung blank po ba yun except for the
Ano, hindi ko narinig yung buong question. You can type if ever. The blank is everything in the sample except the analyte. So kung hinit mo yung sample, i-hit mo rin yung blank. Kung anong treatment ang ginawa mo sa sample mo, gagawin mo dun sa blank. And there are a lot of types of blank. Okay? Yeah. But the thing is, you only apply calibration curve pag walang matrix effect. Yun yung limitation nito. Once you suspect that there will be matrix effect, hindi pwedeng gamitin tong calibration curve. Okay? So you have to take that into consideration. So the way that you do this calibration curve or external standards, so typically that's how it is. So you prepare the different concentration, you get the reading, and then you have the unknown. So once you have the y equals to mx plus b, okay, you get the unknown, it gives you the y, and all you need to do is get the x. So required here that the plot should be linear. So dyan yung papasok yung LDR. And then usually you use the so-called linear least squares within the dynamic range to fit the data. Or I'm not sure if you're familiar with Linus. Did you hear this word before, this function?
No.
So Linus is para din kayo nagka-calibration curve. Ilalagay mo yung XY value and it will give you the different parameters like R squared, slope, y-intercept. Okay. Now, if your calibration is non-linear, you have to fit it. Sometimes pwedeng logarithmic, but it's not really ideal if you have like a curve like this. Okay? Kung non-linear yung calibration mo. So pwedeng i-fit mo, pwedeng siguro logarithmic curve, but that's not ideal. And then the signal from the unknown must be within the range of standard. Bawal ang extrapolation. So if ever yung data mo ay nandito, hindi mo pwedeng i-extrapolate. Anong gagawin mo? How do you solve? You dilute that. Okay? So this is just one calibration methods. Now, if you have a matrix effect, standard addition is the best thing. And again, standard addition can be single or multiple. Okay? So here, what you do in the standard addition, you're going to prepare different solution wherein you're going to add, okay, your sample in it and different concentration of your standard. Yun ay kung marami kang sample. Paano pag konti lang yung sample mo? Ano gagawin mo? You can just use one. Okay? So yung pagdagdag mo nung tinatawag nating standard, that's what we call spiking. And when you spike them, it's a different concentration na, tapos meron kang isa sa mga container na sample lang ang meron, wala kang dinagdag na standard. Okay? So if you only do a single point standard addition, again, it is a ratio and the proportion. Whatever the concentration that you add and the signal. Tapos yung sample mo, tapos yung corresponding concentration na makukuha mo. So if you have a calibration curve type where you use different concentration, what happened is you will have it like this. Okay? So when you have the reading of the unknown without the standard addition, so you set there. So yung y mo, kung ano yung makikita mong reading, okay, tapos i-match mo kung ano yung x niya to get the concentration of the unknown. And again, as I told you, this is useful when you have a matrix effect. Standard addition. Parang calibration curve lang ito, pero yung calibration curve, you don't use it if matrix is not a problem. I mean, you use it if matrix is not a problem, but if matrix is not the problem, the standard addition is the one that is applicable. Questions so far? So in the standard addition, yung parang meron kang tinatawag na standard, ina-add mo directly doon sa alikot. Okay, the addition of known amount of your standard solution is done to one portion of the sample. Kung single point lang yan, ang tinitingnan mo yung response signal or yung signal before and after the addition. Okay? So you measured it and then you use it to obtain the analyte concentration. So if you have the multiple addition, mas maganda yun. Okay, so you have a single point standard addition and a multiple addition method. Parang sa calibration curve din. What's the difference between the two? Yung single point versus multiple. You apply this if you don't have enough standard or if you don't have enough sample. Remember, if you do this, you have equal volumes of unknown pipeted into several volumetric class. Paano kapag konti lang yung sample mo? Or let's say, konti lang yung standard mo because you're going to use increasing volumes of standard added to each class. Okay? And that standard is the one that you're looking for, the analyte. And then you dilute your class to the same final volume. So you have to look at the limitation. Now, the last one, you apply this in what we call several cases. Okay? You can ask yourself, why do we have to do this so-called internal standard? So, whenever, okay, there are occasions where your signal from the instrument fluctuates, what will happen to your result? Whenever you have a sample prep procedure that results in what? Loss of the analyte, it will affect your result. Okay? So when those happen, you have no way to reproducibly input the constant volume of sample into an instrument. So you have to use a standard, an internal standard. Okay? And usually, if you have what we call the internal standard, this is not the same as your standard. But, okay, its structure is at least similar to your standard. Okay, so usually the internal standard that we use is a chemical substance that is added in a constant amount to the sample. Okay, so you just want to know the ratio of your internal standard with respect to your standard. So anong mangyayari yun? So if you're going to look at the what we call thing here, method is based on the fact that the ratio of concentration between the internal standard and the analyte remains constant even when the instrument drifts or the sample is lost during the treatment or not completely introduced in the instrument. For example, this one. So this is how you do it. So you always put the internal standard together with your standards. The standard is your analyte. So what happened? So when the reading here goes down, as you could see, the internal standard signal is also down compared to if it goes up, this is also up. It is much higher and this also much higher. But as you could see here, the ratio that they have would always remain the same. Okay? So yan yung concept ng internal standard. You just take into consideration some steps that might affect, okay, your results. So paano pag wala yung internal standard? What will happen? So you don't know if the sample that you have, okay, really contains the whatever signal that come out there. Question? Tanong sa internal standard? Question, class? So this is the home problem that you're going to do in addition to the quiz that I'm going to open soon. So what I want you to do is maybe solve it, take a photo, convert the photo to PDF, and then upload. Answering the questions that you have there. I'll try to look at the canvas so you will see where it is. So I'm going to try to share the canvas. So this is here. So this is how it looks like when I convert it here. So pwede ko nang i-publish to. Try to see if you can see them.
Ito po yung take home, sir.
Oo, i-upload nyo to.
Kita na po, sir.
Kita nyo na.
Yes.
So, anong oras ngayon matatapos nyo? I set at 5.
5 p.m. po daw.
Gusto nyo baguhin? Gusto nyo patagalin yung paghihirap nyo? I think I set it at 5. Any comment?
Pwede pong medyo later pa po since may classes pa po after.
Yun na nga, kaya nga tinatanong ko na sa inyo. Yung next class nyo ba? 1 to 5? Yes, magsabi na kayo kasi after ng class natin, matutulog na ako. So by the time I wake up, it's past 5 na.
Sir, later po sana. May classes pa po kami.
No, ano nga, sabihin nyo, huwag na kayo mahiya. But I want it by the end of that day until nighttime today. Ano?
11:59 daw po.
And then I think before we meet next week, I'm going to post another take home na parang ganito, problem din. Hindi pumasok. So siguro yung deadline doon before tayo mag-klase. And in addition to that, meron pa kayong quiz, yung 5-minute quiz na 5 question na i-open ko na. Siguro i-open ko na. Sabi yun. So yung isang quiz, 1 p.m. yun. Kita nyo na?
Kita na po.
Sinong wala? 28. So, 3 yung wala. O, sabi ni Seb, magpakita daw kayo.